Okay, hello everyone. Glad to see you. Let's begin. Let me quickly check and make sure that everything is set up. And let me start sharing my screen. All right, so you should be able to actually see my screen now. And today we are going to continue our interview preparation classes. I'm going to continue talking about interview. So yesterday we quickly talked about interview process overall, and we talked about funnel and just the stages that you will see during the interview. So today we are going to first of all finish the questions, interview questions that we started yesterday. And after that, we will move to the next topic and talk about software development lifecycle and just the process and how it works overall in a software company. So let's begin with interview questions. As always, if you have any questions during the class, just drop them in the chat. And I will be just making some small pauses and checking the chat to make sure that I actually answer all the questions that you have. So let's continue. Yesterday, we finished, I think, with question number 4. What would you do once you found a bug? And I mentioned that in this case, basically, you need to reproduce it a couple times, play with it, and then file it. And now let's continue and start with question number 5. So question number 5 is pretty common and appears pretty often during interviews. Um, and it's actually very simple, but for some reason it confuses people a lot. So question number 5 is, how can a tester be sure that a bug has been fixed? Um, so the very simple answer here is basically to open the ticket that is assigned to you in order to test it, and follow steps to reproduce from that ticket. And then basically verify that the issue is no longer happening. That's it. So basically, when somebody finds a bug, they file a Jira ticket with steps where they define what the problem is. And then developer takes this ticket, they fix it, and after that, developers will assign it back to QA team. So now when you get this ticket, all you need to do is just open it, read the steps to reproduce, go to your new build or new web page, uh, basically execute the steps and verify that you no longer see the broken behavior and behavior is now correct. So that is the way to verify that the issue is fixed. That's it. Question number 6. What is the biggest problem issue at work, and how you solve it? So quick comment here. Sometimes during the interview, they may ask you a question, which is just this first part. So they may ask you something like, what is the biggest problem you ever faced at work? Or what is the biggest issue you faced at work? And they may not ask you about the solution. But keep in mind that even if they are not directly asking you about the solution, always try to mention a solution when you talk about specific problem. Now, this question is basically trying to understand two things. One thing, what is the problem? What do you consider problem? And the second thing is basically, how do you solve it, and what's your way around this issue? So when you answer something like this, I would recommend you to come up with something that is pretty generic, and it's a common issue for everyone. So everybody understands it's a pain, and that way that answer will be just more successful because people know what exactly you're talking about. So a good example here would be time constraints. So for example, you can say something like, I needed to work on something, and I was really limited in time. So I felt like I don't have enough time to actually complete this task. Or you can say something that I had to work on multiple projects at the same time, and I was lacking time, so I needed to prioritize things. And this kind of problems actually happen pretty often during QA work or during just work in general. And the solution here, how you solve it, you can explain something like, when I realized that I am behind my schedule and I may not have enough time, I let my manager know about it. I also try to prioritize the most important things to cover them first, like the most important tests to cover them first, and then everything else. So basically, good prioritization and communication with your manager will help to solve this problem. So that would be a good example. I would not recommend you to come up with some sort of technical issues, because if somebody is asking you what's the biggest problem at work that you've seen and how you solved it, and you say something that, for example, I needed to test on a specific device and I was lacking this device, I didn't have it. Yeah, that is a problem. But that's not, the big problem, not something that is pretty hard and usually pretty easy to solve with some tools that we usually have in place for this. So just come up with something that is a little bit more serious and a little bit more general. Timelines, priorities are good examples here. Now the question number 7. Where do you see yourself 5 years from now? Very common question. We usually hear it a lot during technical screens from managers. Managers very often try to understand people's priorities. We also hear it sometimes during the final on-site interview with different team members. And the answer here is basically try to say something that is within QA, and try to say something that is realistic. So the good answer here would be something like, I would like to continue working in QA. Possibly I will turn into a QA lead or a senior QA engineer and will be more involved into more technical testing. Or you can say something like, I think that I will just stay in QA. Possibly I will switch to QA automation. It sounds like an interesting field. I didn't learn it yet, but that's something that is interesting. So that one is also going to be another good answer. Don't mention things that are irrelevant to QA career. So some of the bad answers I've heard was like, somebody told me that they would like to switch to real estate at some point, and they are actually not sure what's going to happen in 5 years. Or also I've heard some kind of weird answers like, I don't know. Maybe you don't know. Maybe you want to switch a career. That's totally fine. Just don't say it during the interview, because think about it from the point of view of a manager. The manager wants to hire somebody who will stay with them for a few years. They will invest their time and the company resources in educating this person, onboarding this person, and making sure that this person basically is able to work and performs good results. So obviously, they would prefer somebody who will say that they are more likely to stay in QA and learn and develop, over somebody who will say that they don't know what they're going to do in 5 years and maybe they switch to some totally different industry. So your chances are just a little bit higher if you basically give the right answer here. Now, a questionable answer here is about development. I hear a lot of opinions. Some people say Do not mention development when answering this question. Some people say you can mention that you want to turn to development. So long story short, I would recommend you to still stick with QA. If you want to turn into a developer, that's okay. After you start working, you can just outline it as part of your goals, and the company will help you to make the switch. That's not a big deal. But during work interview, I'd rather just play safe and basically say that I will stay in QA. And another quick comment here, it'd be nice to also add that you see yourself in the company and that you are looking for basically company where you could work and stay long term. This is what companies want to hear. In average, engineers usually change jobs every couple of years. And we will talk a little bit about that during the next lesson. I also recommend people to change jobs often, but during the interview, you want to sound like somebody who will stick around for a long time. So better mention that you would actually stay in the company. That will give you better chances. All right, let me quickly check the chat and then we'll go to the next question. Let's see. All right. So yeah, thank you, whoever posted the Evgenia for posting the answers. Yeah. So interview questions and answers we sent out over email with yesterday's lesson, and those are in that email. The link to that email in that email. Okay. Cool. So let's continue and let's move on to the next question. So the question number 8. Why did you choose to become a QA engineer? So this one is not super often, but sometimes we hear it. And basically, it's really up to you. I don't have the best answer to give here for everybody. Everybody's story is different. But what you can mention here, if you don't have any ideas or any thoughts, you can say something generic. So you can mention that you were always interested in IT industry, and you heard about the QA bootcamp, and it sounded like a good idea to actually join. So you decided to try, graduated, and joined, and basically that would be a pretty good, honest answer. Now, if you have any background in engineering or development or something IT related, you can also mention that. You can say something that you were in IT industry, you were looking for a switch, and eventually you heard about QA. It looked like a good opportunity. Been through the boot camp and you really liked it, and I decided to turn into a QA engineer. That's a good answer. But keep in mind that this is your story. You can totally customize it. I myself joined QA actually just all of a sudden. I didn't plan on it. I was a gamer and I always liked gaming. So eventually I got a job for a gaming company and I was doing translation and localization there. And then they needed QA engineers, so I decided to try and I switched to QA engineering, and that's basically how I ended up being in QA engineer. So I didn't even go there with a certain purpose. I was just playing games at work, and that's how I ended up turning into QA. So everybody's story is different. If you have something your own, that's totally fine. Just mention this. Just a quick comment. This question is it's very possible you will hear this question. So prepare that one for yourself before you start interviewing. So you don't sound like surprised with this question. You sound confident and basically you can answer it easily. All right, question number 9, super popular. We actually hear it a lot. We hear it during our conversation with HR pretty much all the time. We also hear it when we talk to QA managers and during on-sites. And the question is, why are you leaving your current company? Again, there are no just right or wrong answer. Just a quick comment here with the approach overall. Um, if you're currently employed and you are leaving your company, don't say anything bad about your company. So that's one of the red flags, and people actually test for this. So during your interview, never say anything bad about your current company, current team, current manager. Even if you truly honestly hate them, don't bring it up during the interview. This just doesn't sound good. So the reasons for leaving can be absolutely different. Things like my company is laying off a lot of people during COVID, or things like I'm currently working as a contractor, so I'm looking more for like full-time opportunities, or my contract is about to expire soon, or things like the company I'm working for is a very early stage startup, and I'm looking for something that is more, basically more serious, more settled. You can talk about all these reasons. Besides that, there is another good reason to mention for leaving the company is basically HRs, like from HR kind of books, a good reason, and it is time for a person to leave the company, is when you learn pretty much everything you can possibly learn at this role, and you still need to grow. So it's a good time to move on. So that would be a good answer here too. So if somebody is asking you about why you leave in your current company, you can also say that you basically learned everything, and you want to continue to grow, you want to develop, and you are looking for other opportunities. So those are going to be good answers as well. Cool. All right. And the question number 10. What can you bring to the company? So this is actually a very good question to get, because here you can pretty much advertise yourself. So when somebody's asking you this question, feel free to answer them basically another sales speech about yourself, and tell them that I'm a very responsible and reliable person. I really value quality, and I always advocate for user quality. So I really hope to influence your product. That I really hope that QA processes basically will be better with me here. You can also say here that you know some tools. So you can also mention that I have good knowledge of a lot of QA tools, and I have experience working with web, working with mobile devices, and I can definitely apply it at my next role and actually help discover a lot of issues and eventually influence the product. So all kinds of things about yourself, how good you are, those are good points to say here. So prepare this question and don't be too shy. Definitely try to sell yourself if you get this kind of question. All right, so let me check the chat. We're almost at the end, and let's see. Okay. Okay, let me answer from the beginning. Somebody having issues with logging into yesterday's lesson, contact our support. That's the easiest way. They will reply to you right away. We have a whole team over there. So just send an email to support@jobeasy.co, and they will help you. All right, let's see what else. Let me try to just pick the ones that are relevant. How do we answer the question why QA if we have a degree in computer science? I don't really know your whole story behind, but you can definitely mention that you were always interested in IT and you got a degree in computer science. And if that is going to be your first job, you basically can say that you are looking for opportunities to enter the industry and learn a lot. And that would be a pretty good answer here. Um, Similarly, if it's your first job, also mention something that you're interested in IT. That sounds like a good field to be in. You heard about QA bootcamp, you joined, you graduated from that. It was very interesting, and now you're basically looking for the first job to pursue that career. Um, about leaving, why are you leaving your current company? Can we say low pay? I would not recommend you to say it because you open the door for them to lowball you. Because basically, if you tell them that they don't pay me well, the next company is not going to offer you a lot of money. So I'd rather come up with something different, and I'd rather say some sort of other reason like I'm on the contract, my contract's about to expire, or I've learned everything I could possibly learn over here, and I don't see any perspective, any way for me to grow within this company. We have a very small QA team, or just very small engineering team, and I'd like to explore the opportunities and work on a different product. So I would go with something like that, because really, if you say low pay, they're gonna offer you another low pay. You don't want that to happen. What if you're leaving your current company because it's not QA? Yeah, you can say that as well. That basically you decide to switch your career and turn into more IT industry, and that's it. That's an honest answer. What if they ask, can we contact your previous employer? That's fine. They can. If that is going to be about some of, let's say, school projects, we will help you with that. If that's going to be about like some other jobs that you have, that's totally fine. Usually, there's not a big deal. If you don't want the company that you're interviewing with to contact your previous employer, you can tell them that you are not comfortable with that because that company doesn't know that you are searching for a job. So in that case, if they want to verify, let's say, your background or something like that, they may ask you for a copy of your paycheck to make sure that you actually worked somewhere, but they won't be calling. That's a way around it if you don't want them to contact. Let's see what else. Okay, I think I answered about QA. Have you previously seen someone get hired as a QA engineer if it's the first training and first job as QA? Oh yeah, a lot of people actually. I think we had 16 or 20 people from the school who got jobs last month, and basically nobody had experience. So yeah. So that's basically it. So I gave you a few pretty generic answer. I see a couple of more questions, but they are more like specific to certain cases. You can discuss them with mentors after you basically finish the course, and you have a mentor assigned to you who knows your story. They will help you with certain cases, and they will recommend you some things on how to basically behave and want to answers. But I hope you basically got just the whole idea overall. All right, okay, before I jump to the next one, when do we get the mentor? I think I mentioned yesterday, but just in case, after you create it, after you finish the course, you are assigned a mentor, and that is when you can start talking to them. So basically, finish the course, finish the internship, talk to mentor. That's the plan. Cool. All right, so let's continue. Let's go to today's topic. Just a quick comment. I have two more questions on this slide, 11 and 12. They are the question about strengths, weaknesses, and the question about what to do in case of personal conflict. I attached the links to my YouTube videos about those. So if you're curious how to answer those, feel free to just click on those links and watch YouTube videos. They are about 10 minutes each. I don't really want to spend too much time on those during the class. So on the slides, if you just click on the slide, it will take you to YouTube channel and you will see the video. So let's continue and let's go to today's lesson because we are a little bit behind. Today we are going to talk about types of testing and software development lifecycle. So the first thing that we're gonna start with is basically we're gonna go over types of testing. One more time, really quickly. I know that you covered that at the very beginning of the class, but it's super useful for you to actually have some understanding and knowledge of it right before you start looking for a job. And because this terminology pops up often, we basically want to go over it one more time really quickly and make sure that you have your chance to ask the questions. All right, so let's begin and let's quickly start with the testing types. So first of all, before I start jumping into the definitions and things like this, the very common question I get here is, do we have to learn these definitions by heart? Do we have to know all of this? And are people gonna ask us the definitions? Are people gonna ask us what is a black box testing, what is a white box testing, and things like this? And the answer here is actually no. So usually when you start interviewing, nobody's actually asking you for the definitions, and nobody's going to be asking you things like what is a black box testing or define white box testing. That's not going to happen. So you don't need to learn the definitions. But what is going to happen most likely is that during the interview, somebody may ask you like, are you familiar with black box testing? Do you do any of the gray box testing or only black box testing? And you should be able to answer that kind of question. And in order to answer it, you should understand what the person is talking about. So that's basically the whole idea, and that's why it is important to just have a good understanding on different types of testing that we see when we start working as QA engineers. So the first classification, there are a few classifications that divide types of testing in different types, but the first classification, the most common classification we have, divides all testing activities in basically three types: black box testing, gray box testing, and white box testing. So black box testing is something that manual QA engineers will be doing for 99% of their time, pretty much. Basically, this is the approach that basically takes our app as a black box and we just execute the test cases. So with black box testing, we usually have zero knowledge about the actual structure of our app, what is inside, and how it works. All we need to do for black box testing is basically have an app or have our web page, have a set of test cases, and just go and execute the test case. We don't look on what's happening inside the app. We don't look at what's happening in the database. We don't look at the code at all. All we do, open the app, open the spreadsheet with test cases, and then one by one execute the test case one after another. So this is the black box testing. Again, not looking anywhere inside our actual app. Now, the gray box testing, is the testing that we use when we actually have some knowledge about the internal structure of the application, and we apply it in order to test something. So one common type that I would mention here as an example is testing something and looking at the API calls. Let's say you open your web page, you go to login, you input your email and password, you open Chrome Developer Tools Network, and you click login button. And now when you log in, you see an API call, basically request that's sent to the server. You can see what was sent and what kind of response you get back from the server. So that will be one kind of gray box testing, because you are actually looking inside a little bit. You're looking at what's happening inside. Another example here would be testing activities related to any kind of database validation. So for example, you go to your user registration page, you create a user, then you go to the database and you verify that after you created the user record appeared in the database, and the information that you have entered during the registration actually matches this information that you see in the database. So this is also going to be gray box testing. We usually don't do that often when we do manual testing, but that kind of activity can happen sometimes. And at that point, we actually have to look a little bit behind the actual interface we're working with and look a little bit inside the app. And that is a gray box testing. Now, the third type that we usually see here is white box, or some people call it clear box testing. And this is the type of testing that basically tests internal structures of the whole app. And usually this type of testing means that we have access to pretty much all the internal parts of the app. Usually we have access to the source code. And basically when we write the actual code, we also write the tests, the unit tests for, let's say, each function of this code. And that is going to be a good example of white box testing. So this is done by developers. QA engineers don't go to this land. Even QA automation engineers don't go here. This is done by developers, sometimes by software developers and tests. But again, this is the land of developers. This is the part that's usually done by manual QA. A little bit of gray box testing can also be done by manual QA. So that's it. Are white box and automation the same? No, we will talk a little bit about that during one of our last lessons. QA automation is actually a kind of a black box testing. Sometimes parts of the automation can touch gray box testing, like automation of API testing will be gray box testing. But white box testing or unit testing, this is activity of developers, and it's different from QA automation. Yeah, good question. Cool. So let's continue and let's talk about the next classification that we have. So the next classification, actually, before I jump here, I think I have one more message. Let's see. Can you give us another example to talk about gray box testing? That's a good question. Let me think about it. Well, that's probably going to be a little bit harder to explain. But for example, if you, let's say, if you're working with your app and you are using logs as a way to actually read on what's happening in the app, that is kind of gray box testing. So for example, you are using your mobile app, you install it, and then you do some actions in your mobile app, and you also track all the logs that are happening in this app. at the same time and you're reading what's happening in the logs, that would be also gray box testing because you basically have access to another internal case. Is SQL gray box testing? Yeah. SQL, any types of database validation will be gray box testing. So any types of testing related to, let's say, marketing events. So for example, when you open your app, go through a few screens, we send information to our marketing database, basically saying that a user clicked on this screen, the user clicked on another screen, the user went to the third screen. That is also gray box testing, and we are also likely to use SQL there as well. So yeah, that will be gray box as well. Okay, so let's continue. And let's talk about the next classification. And the next classification will be dividing testing into two types, functional and non-functional. So this is quite simple. Functional is the type of testing that verifies that functions of our software, basically functionality, works as expected. And non-functional testing touches all the aspects that are not related to the actual functionality. So a very simple example here, let's say you test a YouTube page, the page where you can actually open the video and you can play it. So the functional testing will be all kinds of testing activities around the actual functionality, right? So what is the functionality of this YouTube page? You should obviously be able to play and stop the video. You should be able to probably fast forward the video and like go back in the video. You should be able to add this video to the playlist, like, dislike, leave a comment, search for another video. So all those things are functional. All those things are responsible for the actual activities you can do inside your web page or your app. So those are going to be functional tests. And non-functional aspects, they basically check things that are not related to the functionality. So for example, verify that YouTube page has the correct YouTube logo on top, that YouTube page, when you open it, has the right colors. The background is white, the font is black, the font has the right size, and the styling just looks correct. The page doesn't look broken, right? Also, things like performance. So, for example, you open your page and you just wait until it loads. Obviously, when you open a web page, it should load pretty fast within a couple of seconds. So that is going to be performance testing. If it's slow, if it takes, I don't know, 15 seconds to load, that is actually a bug. So that is another non-functional aspect. You don't do any, activities in the app. You just look at the page, look at its styles, look how fast and quick it loads, and that is going to be non-functional testing. Let's see what else. Is security testing functional or not? That's a good question. I'd say it's probably a not functional testing, but I would recommend you to look it up actually, because I feel like some of the security tests can be functional and some can be not. I would still lean more towards non-functional, but I would look it up actually. Let's see what else. In your YouTube example, is there a listed structure, for instance, or of what to test around on the page, or are we more randomly going around the page testing all we can? If you are asked the question like, how would you test a certain page? And let's say you are given YouTube as an example, you always start with the most important tests. So you always start with functional positive test cases, and then you go with everything else. So in my example, I just basically listed a few things that you can test that are positive test cases, like playing the video, stopping the video, fast forwarding, going back, and so on. But usually when you start testing something, you just open the page and you come up with your test cases from like this functional positive test cases first, and then everything that is less important or negative or non-functional aspects after that. So that's usually the structure you want to follow when you actually start testing something. Okay, I hope that makes sense. Cool. So that's basically it. Now, the next classification that we have, actually, before we jump here, let me go back 1 second. Let's see. Do the manual QA perform the non-functional testing? Yes, it's usually related to UI testing. So everything related to actual interfaces we test, right? So let's say you are making sure that your button has the right size, that the button doesn't overlap something on the page. So UI or graphical user interface is the most common things that manual QA usually tests. At the same time, things like performance, usability, reliability, those types of tests usually are not done by manual QA engineers. They usually done either by developers or by QA engineers who specify in that particular field, because that's a whole another world. Is it better to say that we have experience in the gray box testing? So if you understand how to look at the network and look at the client-server communication, also if you understand how to make basically searches in the database and get data in the database and validate something, you can definitely mention that, yes, you know gray box testing. At the same time, if you're not comfortable with that, if you don't understand how that works, then better not mention that and just say that you only do black box testing. That's the approach I would recommend you to take. As far as will it give more competitive advantage rather than saying that just black box testing, yes. So if you know more technical things, that is usually advantage, and that usually gives you higher chances to get a job. You can get a job without it, but your chances of getting it with knowing SQL and knowing a little bit about API testing are much higher usually. Yeah, that'd be true. Okay, cool. So let's continue. So the next classification that I wanted to talk about today divides our testing into two main kinds, which are positive and negative. We also define boundary testing, but that's more like a technique. So I'm going to talk about that in a second. So first of all, positive testing and negative testing. So positive testing is a type of testing that we do by basically providing valid data inputs, and we verify that our app behaves as expected with these positive inputs. Negative testing basically tries to verify the cases that mimic unexpected user behavior or invalid inputs. And it tries to make sure that our app can handle these cases nicely and nothing's going to break. Now, in human language, basically positive testing is when we do things that our users would do. So for example, if you open the registration page, and this registration page is asking to provide first name, last name, email, and password, positive test case would be to open this page, provide first name, last name, email, password that matches their requirements, and then click sign up button so user will be created. So we basically do the thing that most of the users would normally do, just provide valid inputs and verify that app works so our user gets created. Now, negative testing is basically test cases when we act weird, when we do things that users shouldn't do or regularly would not do. For example, we go to this registration page, we try register, we provide, let's say, first name, last name, email, but we don't provide any password. We keep it blank, and then we click sign up button. In that case, our app should show us an error and say, hey, you can't sign up without a password. So that would be negative testing, basically verifying those scenarios when we provide invalid inputs and we do some things that users shouldn't be doing. Another example here, let's say you try to sign up and you provide the password that doesn't match the requirements. That is also would be negative testing, right? If the requirement says that the password should be at least 8 characters or more, negative testing would be to, for example, create a password that is 7 or that is 1 and verify that our app still won't create a user and show us a normal error message. Or try to register and provide invalid email. Another case, negative test cases. In this case, app should also show an error message and say, hey, this is not a valid email. Please enter a valid email. So something like this. So that's basically the idea. Positive tests is when we do things that users would normally do, valid inputs, valid data. Negative testing is basically when we try to break things and provide invalid data, invalid inputs. Now, a common question here, let's open calculator. Sometimes I hear it during the interviews is, let's say you test a calculator. What would be positive test cases for a calculator, right? So again, positive test cases means do things that users would normally do. So for a calculator, it would be something simple. 2 plus 3, verify that it returns 5. 5 minus 6, verify that it is minus 1. Even if the number is negative, it's still, the test case is positive because this test case is something that users would normally do when they use a calculator. This is an absolutely valid number. Minus 1, I don't know, times 6, verify that it still works. So all those test cases are positive test cases, things that users would do. Now, the negative test cases for a calculator will be basically tests that will check the cases when we do things we shouldn't actually do. So for example, let's do 2 divide by 0, right? You shouldn't be able to divide by 0. So that is a negative test case. And our calculator should handle it. It shouldn't crash. It should tell us this is not a number. Or for example, you can try to take a square root out of negative number. That would be another negative test case because square root means positive number. You cannot take a square root out of a negative number, and your calculator should handle those things. Another case, let's say you work with a calculator and you try to input some sort of a number that is more than what your calculator can do. So you like create super large number. And then you verify that at some point you either see like an error message saying like this number is too large, or your calculator handles that kind of situation properly, or super small number. So things like this. Those would be negative test cases. All right, I hope it makes sense. Let me check the chat. Who is going to provide the username and password for positive testing? Usually when you join a company, they will give you a certain environment, like a certain build to test on or a certain website to test on. And you can create as many users as you can to actually test there. So usually we just, in the test case, we would put like one of the steps, create a user, and then the second step, log in as a user, and the third will be like verify something. So basically you will be creating your own users and then validating things with those. Let's see what else. Not sure I understand the question. How about we're learning just basic means less chance to get the job? You can definitely get the job with just basic QA knowledge and things that you basically learn. Keep in mind that things that we actually have in this course are a little bit more than just basics. So your chances should be pretty high. Um, Cool. Let's see what else. Can you tell the differences between ad hoc and monkey testing, please? Honestly, I don't know. I always thought that that is the same thing, but you can probably look it up. In my opinion, ad hoc testing and monkey testing, just from what I've heard, always means the same. But you can probably Google and validate. Actually, I've never heard this question before. So that's a good one. I will look it up after the class myself. All right, so let's continue. And let's talk about the next thing, the next technique, which is a boundary testing. So boundary testing is actually a technique that combines both positive and negative tests. And it usually is used when we need to test around a certain border. So, for example, you need to create a user and you have a registration page. And this registration page is asking for user's age. And then you input your user's age, and the valid age is between 18 and let's say 150. So if you're user 18, I don't know, 30, 150, they are allowed to register. And at the same time, if you input something that is less than 18, you should not be able to register. Or if you input something like over 150, then you should also not be able to register because at this point, that's basically too much. That is more than our allowed age for registration. So boundary testing will basically help us to test around the borders. When you see rules like this, the right approach to testing this will be to actually verify values around the borders of your testing. So basically, when you need to check this value, at first you take the positive inputs. So your lowest positive input over here is 18. Users who are 18 years old should be able to register. Then you check the max positive input, which is 150, right? So 18, you verify that you can register it as user. Then create another user, pick 150, verify that you can register it as user, and then pick a value in between. That's just a good practice of boundary testing, and also verify that you can register as a user who is, let's say, 20 or 30 or 84, whatever, just something in between. And then besides that, another two things to test here are two negative checks. So basically you take 17 and 150 and you verify that you cannot register with these values. And that is the way to test your borders and to verify that things are correct. It's called boundary testing because we basically test around borders, right? So our first border is 18, so we test 17, that is below that, and then we test the value on the border 18. And then our second border is 150, and we verify that we can register with 150, and we cannot register when we go outside of this border with 151. And then we also take one value in between, which is 17, and just verify that, which is 20, and we just verify that we can still register. That's it. So that's boundary testing. Again, just testing around the borders. Another example of boundary testing will be, let's say, testing a password field. So very often when you try to create a password, websites have at least one border that says that your password cannot be shorter than, let's say, 8 characters. So 8 here is also your border. So the way to test here would be to just take a password that is 7 characters, try to register with it, verify that you cannot, then create a password with 8, try to register, verify that you can, and then take one more that is also another positive check. So take something like 10 characters or 11 characters, for example, and verify that you can still register with that password. So that is basically the boundary testing technique. Again, it just combines both positive and negative checks in order to test better around a certain border. That's it. All right. So let's move on and let's quickly talk about the next classification of testing, which separates our tests into unit, integration, system, and acceptance testing. So very quickly, unit testing is our basically lowest level of testing when we test individual components. And that is something that's usually done by developers. So as a developer, I create a code for my app, and basically the code contains a bunch of functions. Unit tests will be testing separate functions and verifying that they all work basically. At this point, we just work with the code. We don't work with user interface. It just basically could work in this code. That's it. Now, if we go a little bit up, we get to integration testing. So this is when few units are usually combined and tested as a group. So for example, you have a backend server and you have a database. And you need to verify that your backend server can access the database and let's say create a user when you call certain functions on your backend server. Integration testing will verify that the server can access the database and they can work together. This is also done by developers, and usually we don't touch this land. This is usually just built by people who are responsible for building these components. Now, if we go a little bit up, we'll get to system testing. So system testing verifies how different components of our app interact basically as a full all together. And basically we verified that our system works as designed. So you have a website, you can open it, you can, for example, go and register. And when you register, your client side interacts with the server side interacts with the database, and the whole system basically up and working. So this is high-level system testing. If we go a little bit more up, we get to acceptance testing. Acceptance testing is basically when we test our system for acceptability. So we not just verify that the whole system works, but we also verify that it works according to our spec, according to our requirements. And this is usually where we live, where most of QA activity is happening. So we compare our requirements with the way it actually looks or actually works, and file bugs if we see mismatches. So this is acceptance testing. Now, sometimes some companies can also have alpha and beta testing. Both alpha and beta testing are subtypes of acceptance testing. And they are different kinds of testing that the company can perform in order to make sure that the quality of the product they deliver is good. Now, alpha testing is usually performed by internal users of the product before we release to the public. So for example, here we build a system, we started tested as QA engineers, we verify that it works, our QA team goes through the site, looking good. Now we, let's say, want to release this website to the whole external world, but let's say we have a lot of functionality, we're afraid, we're not sure it's just going to be good. So at that point, the company may decide to go and do alpha testing. So what they're going to do, they're going to take this website and release it to internal users. So everybody who works for this company now has access to the site. And that includes not just QA, but people from, I don't know, finance, marketing, customer success, whatever. Now everybody can go access this website. Sometimes it also friends or family of our company employees. And basically, everybody can just go and play with this website. So we have more people who actually test our system. They're not QA engineers at this point, not only QA engineers at this point, but still we have a bigger audience, so we can verify that our system works on different devices for different users, different computers, and so on. So this is alpha testing. It doesn't have to happen. In fact, it usually doesn't happen often. It happens usually before very large releases, but that may happen in a company. Now, beta testing is when we release to a limited number of end users. Usually it happens with gaming. If you are ever in the gaming, you probably heard something about beta builds or games released to beta testers. So what happens is that when company who, let's say, works and like creates a game, releases a new version, it usually goes to the millions of people. It's literally hundreds of thousands of people. And the price of a bug here is pretty high. So what they usually do in order to just play safer is that they have a limited pool of beta testers. It can be 3,000 people, it can be 10,000 people, it can be 20,000 people, but it's not millions, it's a few thousand. And they release the game to these people. Now, for usually a couple of weeks, maybe a month, they just collect the feedback from those beta users and basically keep on fixing bugs. And that will provide us more confidence in our release because we basically distribute to a big amount of people. And in here, we are more confident with things we are deliver. Obviously, this is expensive and this takes time. So again, this is not something companies do often, but it's something you can see before major releases, especially in gaming industry. So beta testing. All right, and another subtype of acceptance testing is called end-to-end or E2E. So this is the technique that verifies the flow of our app from the very beginning to the finish to make sure that the whole flow works. End-to-end testing is usually done by QA engineers during the acceptance testing. And during end-to-end testing, we're basically going to follow the full user journey, full flow. So let's say if I'm testing Amazon.com, end-to-end test case would be to go to Amazon.com website, create a user, then go to catalog page, find the product, make a purchase, go to checkout, basically complete this purchase and verify that the user information at the end of the purchase matches to what I entered when I registered my user. So the whole data flow, like within this whole app, is normal and everything works together. I can basically go from one experience to another, follow the actual user flows, and it all works together. So that is end-to-end testing. All right, so let me quickly check the chat before we go to the last slide related to our testing. But let's quickly check the questions. Let's see. So when you start testing, when you start working for a company, it's not like the company will tell you, you will only be doing positive tests, or you will only be doing, I don't know, functional tests. Usually we do different kinds of testing. So most of the time we will be doing positive and negative tests. There are definitely more positive testing than negative testing. Most of the time we will be doing black box testing. Also, sometimes we may be doing a little bit of gray box testing here and there. But when you start working, it usually will be just a combination of all kinds of things, a little bit of each. Usually things start with positive functional testing, and then they go to negative functional and just non-functional tests at the end. But again, it really depends on the company and how much testing they want to make, and it's usually just a mix. So an API call test can be categorized as integration testing. Yes and no. It really depends. I would not categorize API test as an integration. I would actually probably call it API test because when we do API testing, we basically verify that our server works and provides the right data. And it's not necessary includes communication with a database. It may not, but it doesn't have to. So I'd probably just call it API. I wouldn't necessarily say it's integration test. At the same time, I've definitely seen people who actually very insistent that API testing and integration testing is the same thing. So if you hear something like that, don't be surprised. There's a lot of confusion in the industry around these things. I've heard developers saying that API testing is a black box testing. And then I've heard more developers saying that API testing is actually black box testing, gray box testing, I'm sorry. I've heard QAs saying that API testing is gray box, and then I've heard QA managers who were absolutely sure that API testing is a part of white box testing, which is totally incorrect, right? So there are a lot of like this questions and confusions in the industry. So don't be surprised if you hear something different when you start interviewing. At the same time, if you want my opinion, I'd probably separate API and integration and put them in the different buckets. That's a hard question though. Cool. All right, so let's continue and let's talk about the last thing that I wanted to mention for today, which are regression, smoke, and sanity tests. We're going to be talking about those more detailed in about 10 minutes. But for now, just a quick reminder and definitions. Regression is the type of testing that we do in order to verify that our program works as expected after the recent changes. So we basically make a new build or we change something in the app. Regression testing is a type of test that will verify that we didn't break everything. And during regression test, we will go through multiple test cases. We will test the whole app basically, and we verify that everything works as expected. So here we will go through, I don't know, 300-400 test cases and verify that we can do everything and nothing is broken. So let's say if we have a new build and we changed some small thing around user login, regression testing will test the whole thing. It will test user creation, payments, accounts, whatever, and login as well. But it will basically retest the whole app in order to make sure that nothing else broken. So during, let's say, changing login, we didn't break logout, I don't know, payments, or who knows what else, because that happens. So that is regression. Usually we go through a lot of test cases here. Now, besides regression, two other types that we sometimes hear during our activities are smoke and sanity testing. So smoke testing is the kind of testing that you do after you receive a build. to make sure that this basically build works and you can continue doing the testing. So, for example, developer fixed a bug and send you a build. Smoke testing will be just opening this build and very quickly go and do things like log in, log out, I don't know, a payment, user creation. So just really quickly check the main functionality to make sure that the app works overall, it doesn't crash. Because if a developer fixed a bug and you downloaded the build, try to log in and your app doesn't log in, it doesn't make sense to go through the full regression and execute 400 test cases. If login doesn't work, we send it back right away and say, hey, fix this. So smoke testing will be just basically this quick verification before we start doing the full regression and before we jump into the nightmare of executing multiple test cases. So smoke testing is just a quick check to make sure that the major functionality is not broken and the app is working. Now, sanity testing is basically kind of testing that we perform after we receive a new build to verify that the functionality was fixed or was changed and no major changes, no major bugs were introduced after the fix. So our developer fixed our login bug. Sanity test will be just go to login and verify that we can log in and the bug is basically fixed and there are no new breaks around it. So with all this picture, basically, let's say you receive a new build and this build includes a bug fix. So let's say you had an issue when your users couldn't, let's say, pay with a certain credit card, totally random. So it was a bug. Users couldn't pay with, I don't know, Visa cards for some reason. So that bug was reported. Now, when you get it back, the smoke testing will be to go to this build, quickly verify login, log out, payments, and make sure that just the build works overall. Sanity test will be basically after you did smoke, go to that payment and verify that the issue is fixed. So now your users can pay with a certain card that was broken before. So this is a sanity check. And then regression tests will be to go through this whole app that you have and execute, I don't know, 300-400 test cases to validate everything in the app and to make sure that everything is still working, even things that are not related to this bug fix. So that is regression. I hope this makes sense. We will talk a little bit more about them now, and I'm going to open this document. So the next thing I wanted to talk about is basically to talk about just the whole software development lifecycle in the company and how the whole process works. But before we get there, let me quickly check the chat and let's try to answer this. Let's see. Do we do regression testing after a bug was fixed? So usually not everywhere and usually not every time. The short answer, regression is expensive, right? It takes a lot of time to go through all those test cases and execute them again and again. So usually people don't do regression after each bug, and they usually do regression testing before they release. So when they have a stable build, that's when they go and do regression testing, not after each bug. That's what people usually do. So we go in order: smoke, sanity, regression. Yeah, you can follow that order. Keep in mind, sometimes you can skip regression. If, let's say, you have 2 tickets to verify 2 different bug fixes, you basically do smoke once, and usually it's the same build. You do smoke once, then you check sanity, check first ticket, verify it's fixed, close it. Check the second ticket, verify it's fixed, close it. And then at the end, when this build will be going live, that's when you do the full regression usually. little unclear, smoke insanity. So yeah, smoke will verify that the whole functionality, the major functionality works. It doesn't break, right? So with smoke, you will always test things that are critical for us. User creation, login, logout, payments, major functionality of the app. Sanity will verify the only functionality that was fixed or was changed, right? So let's say your developer fixed a bug related to login. With sanity testing, you only go to login page and verify that this bug is fixed. That's basically sanity. You will not touch anything else. At the work, who usually instructs on what type of testing should be completed? QA manager. Yeah, usually QA manager, but um, let's go through the process, and I hope after the whole process it will be a little bit more clear. Sometimes you don't actually need any guidance on what kinds of testing to do, because you kind of understand as you go what to test. So let's talk a little bit about process and just the whole development process, and what kind of role QA plays when we start working in an engineering team. So in this document, I have basically just outlined an average process that I usually see in majority of the companies that we follow when we try to build a new feature, or let's say fix a few bugs and release a new build. Keep in mind that this process may be different, right, depending on the company. It's totally possible. It's okay. And just a quick comment, every stage where QA participates is highlighted in green. So if you see something green, that is the time for QA to actually participate in this process. So let's begin. Imagine you work for an IT company, and your goal, the goal of the company is actually to develop and release a new feature. So the common question is actually, how do we do this? How this whole process work? Where do we start? So the idea is actually very simple. Everything starts with an idea. So we have a product team, and product team is the one that usually comes up with different ideas, or they call it hypothesis around our product. So they may come up with certain new functionalities that they want to add, or certain changes that they want to implement in the current functionality. And usually they save these ideas and go through them themselves and try to prioritize them. So a product team gets together, they usually talks to business owners as well, and they try to understand what's more important for business, what they want to build next, what they want to work on. So they come up with a few ideas, and then they prioritize one or maybe two of them for implementation. So now they decide, okay, the next thing we're going to be working on is such and such. After they came up with a certain idea or a certain thing to implement or change, they obviously need that to be built eventually by developers. But developers, they have no idea how it should look, right? So product team actually goes to designers first, and then they work with designers to come up with a mock or with a design document that will basically have the screens that they want to build. So basically, design document will just show images of certain screens, totally static, with like, this is the screen, this is the buttons, links, and so on, and will explain us how a certain feature should look like. So let me actually, we actually go here. I think I have an example. So for example, it will look like this. Designers will come up with a few screens, and they will say like, this is the first screen. From here, user can click continue, go to the second screen, and then go to the third screen. This is something you will see in a design document. Just basically images. That's it. Now, after product team works after product team works with designers, and they have some sort of file that they can show us, they go and talk to engineers. So now we usually have a meeting where product team talks to front end, back end, ideally QA, but sometimes they forget about us, which is not cool. And during that meeting, they will show us these designs and basically ask us what they think, what we think, if we can build it or not, how long will it take, and basically try to estimate things at this point. So over here, let's say they show us a few screens, and our front-end engineers start asking questions, or QA engineers start asking questions, and we also can say if something is impossible to build or very hard to build for front-end engineers, they will probably tell over here. And it's possible that designs and this product specifications, product requirements will change depending on engineering feedback over here. So now after we discuss the spec, usually we provide some feedback and product team updates this document. Design also gets updated. And eventually these documents get just polished to the point where we see more stable designs with basically more final version of what we need to build. Then our product team creates certain user stories and puts them into backlog. So a user story is basically a description of a certain experience from user point of view. So for example, here, basically user story would be like, as a user, I want to be able to navigate from onboarding screen 1 to onboarding screen 2, or as a user, I want to be able to close onboarding by tapping on closing X icon. Or as a user, I want to be able to basically select the recommendations from here before navigating to the next screen, right? So they will come up with multiple user stories that will actually define experience from a user perspective. And those stories will be put in the Jira. So Jira is our project management and bug management basically system. So all the tickets will go there, and eventually they will be put in the Jira backlog. So backlog is just basically a place in Jira where we keep all the tickets that we will be working on at some point in the future, but right now we are not working on them. They are just there for future work, but not yet. So after we have these user stories in the backlog, at some point, our product managers understand that, okay, this is the time we should start working on this new feature. And they will try to add these user stories, these things that we will need to build. They will start adding them to the sprint. So sprint is usually a short development cycle. Depends on the company. Usually it's 2 weeks. For some companies, it's 3 weeks. But it's basically the short period that we use in order to build a certain piece of functionality or certain build. So during sprint planning meeting, all the engineering meets with product managers, QA, and so on. And we all pull these tickets from backlog into the current sprint. So basically, when we pull a ticket from the backlog to the current sprint, we basically say, okay, during the next 2 weeks, I will be working on this ticket, right? So during the next 2 weeks, I will be building such and such. Now, this is basically what you do. Also, during the sprint planning, developers usually estimate this ticket, so they will tell how long it will take them approximately to build this screen, that screen, and so on. As QA, we usually help them with estimations. So we, during sprint planning, can provide information on how long it will take us to test such and such functionality. That is usually responsibility of a QA lead or a QA manager. But that's basically it. We usually don't do anything else besides that. Then after the sprint is finalized, we decide what we're going to be working on. We usually start our sprint and developers start working on our tickets. So at this point, after the sprint starts, developers have these tickets, and now they will start building actual functionalities. They will build the first screen, the second screen, and so on. It usually takes them a few days before they produce at least one build. So during first 2, 4, sometimes even the first week, we usually don't have anything to test at that point. During that time, developers just build actually the first version of the app. So during the beginning of the sprint, we as QA engineers analyze business requirements and work on the test cases. So now we have this design, we have a product spec that describes what a certain functionality should be doing. And basically we will come up with test cases for each and every screen and put those test cases into the test trail. Again, at this point, nothing to test yet. We just come up with test cases based on what we see here. Then eventually, after let's say 2 to 4 days, we get the first build. So after we get the first build, at first we do smoke testing, right? So very quickly verify that it doesn't blow up on the high level. So it works. We can log in, create users, major functionality is okay. And then we start doing some exploratory testing of the new feature. So basically, we will just be opening new feature, making sure that it is there, it can be open, it doesn't crash, it happens all the time, and just verify that on the high level it works. Developers will start moving their tickets one by one to QA. So at that point, let's say developer sent us a build. Let's say they finished a couple of screens and they will move the tickets to QA. So now we will need to test those tickets. So now we will get this user story that says, as a user, I want to see onboarding screen 1. We will take this story, we will open the requirement, and we will compare that with what we see in the app. And we will test, and if we find any issues, we will report them in Jira. So after we tested, if everything is fine, if let's say the screen looks fine and it's not buggy, we just close the story. If we find some bugs, we report bugs. We keep the story open until bugs are fixed. And then eventually after they fix the bugs, we close the story and close all the bug fixes that they sent back to us. So basically we get a few tickets, we test, we provide the feedback, and then we have a basically period of just back and forward with developer again and again. We will be finding new bugs and we will be reporting them, they will be fixing them, and they will be sending them back to us to verify. We will be retesting them, finding new other bugs, sending them back to developer. Well, you got the point. So sometimes it can be 2 builds, 3 builds per day. If they fixing a lot of issues, that's totally fine. But usually after a few days of iterations like this, we get to the point where we come up with a pretty stable build. So most of the issues that we discovered by that time will be fixed by developers. We can't find a lot of new bugs. And at that time, we usually create release candidate build, or basically developers create release candidate build. Now, there is no difference between the release candidate build and the build we got before. it's the same thing. It's just called the release candidate because this build at this point, it's more stable. So it has a tiny little chance to eventually be the last version and the last build and go to production. That's why we call it release candidate. But in fact, it's pretty much the same as the builds before. It's just called this fancy way because it has high chances to go live. So at this point, let's say it's about 4, maybe 3 days before the end of the sprint. Some companies also implement so-called code freeze. A code freeze is basically just the time when they say that, let's say if it's 4 days before the end of the sprint, we no longer develop any new functionality, we only do bug fixes. So at that point, there's going to be no new features coming from developers, only bug fixes. We will be filing more bugs, they will be fixing them. That's it. Now, after we have our release candidate, at that point, we feel pretty confident about the build. We feel that this build looks good. New feature looks pretty good. This build has a high chance to go to production. And here we go. This is the time when we start doing regression, right? So don't do a regression over here at the very beginning because the likelihood of something breaking is very high. But you do a regression at the end after you've already tested a couple of different builds, after it's already pretty stable. So you basically save yourself some time. And here at the end, basically, of our sprint, we do regression testing, and we also finish our testing of the new feature. Now, if during regression, we find a certain important bug that needs to be fixed, what usually happens is that we report it to developers, and then developers create another release candidate build, send us a new release candidate build, and ideally we should do regression again. So we should retest here. So if, let's say, regression is 400 test cases, and during 400 test cases, you find one pretty important bug, and they fix it again over here and create a new build, ideally, you should do a full regression again. So after you got a new release candidate, you should go through these test cases again. So usually there are a few people on the team that do regression at the same time. So usually it's not like one person is responsible for everything, but keep in mind that if release candidate isn't very good and you sending it back again and again, it's possible you will be doing regression testing maybe 2 or even 3 times within the same sprint. So at the end, again, doing regression and finishing the testing. Eventually, after we realize that everything is good, we basically say that build is good to go. And by the way, the latest regression, the last round of regression, some companies, they call it release acceptance testing. So release acceptance testing is usually pretty much the same as regression. It's just some companies actually call it that way to just clarify that that is the last round of testing. After we finished our regression or release acceptance, whatever we call it, we have a stable build and we are ready to go live. We are ready to release it. So while we are still finishing the testing, our product managers come up with release notes, and then eventually we just go live and we release this build to production. Release notes will be posted. And if you ever tested the mobile app, if you go to the App Store, you will find for every app you use, you will find release notes in the App Store. So release notes will pop up there. And release notes just include a quick summary of changes that were implemented in certain apps. So let's say we added a certain feature, I don't know, we healed some bugs, that will be in release notes, and users will be able to basically see what has changed for a certain update. So after we release to production, That's actually not the end of everything. We do production testing. Now, this actually depends on the company. The depths of the production testing can be very different. So, if you work for somebody who is, for some company that is a fintech, like finance, banking, or something related to healthcare, it's possible that after they release to production, they go and do the full regression in production. It is possible. Majority of companies, though majority of startups, they actually not going to do the full regression in production. What they will do instead is going to be just a quick smoke and sanity testing. So they will just verify very quickly that the major functionality works and that the new feature that they just released or new bug fixes that were just fixed also made it to production. So it is there and it's good. But again, it really depends on the company, how deep production testing is gonna be. You will learn it when you join. And after production testing, basically build is available to our users, or our web page is now available to our users, and users start using it. At some point, we have end of the sprint, and we also have sprint retrospective meeting. That is the meeting that we usually host during like the last day of the sprint. And this is the meeting where the whole engineering team meets and we all talk about what went well and what are our areas of improvement. So here we will talk about the past 2 weeks, the past sprint, and we will try to come up with items that we should keep on going, that things that went really good and things that didn't go well. So things that usually come up here on the positive side can be things like the build that developers initially sent us was really good. We didn't find a lot of bugs, so testing was quick. We released successfully. Everything's great. It's fantastic. People love us, right? Another kind of positive things can be, let's say, we had a very good product documentation and we had a very detailed design. So it was very easy for us to test and it was very easy for developers to build. So again, things were very fast. Things that usually come up on the negative sides are quite opposite. So, for example, we were waiting for a build from developers, but instead of sending us the build on, let's say, Thursday, they sent us the build on Tuesday, 4 days before release, and we were very limited in time, so it was hard for us to do a very good testing. Or, for example, they made a build, but it was super buggy. We would find a lot of issues. We were reporting them, so it was taking longer to develop, a longer time to fix the issues. And eventually, it took us longer time to test or longer time to release. And maybe we had some deadline, like basically, maybe we broke some deadlines and maybe we were late. So all those things, they just got discussed during the sprint retrospective. And the point of this procedure is basically to analyze the process and improve it. So if there is something to fix, we can actually fix it. And if there is something that we like and we should keep on doing, we will be doing it. So that's basically it. That's how it goes. Now, one more comment for you. After you release the build to production and test in production, don't think that that is it. Don't think that, okay, the story is over. Actually, there are teams that are there, and the teams that are working with our users, the teams that will be still monitoring our production. So a product team will always be monitoring all the reviews that go about our build, that goes through the App Store, that goes through any other ways of communication, even in Twitter. That's pretty common these days. And they will notice if users complain about certain bugs, they will likely go back to QA and say, hey, users are complaining that they cannot open a certain screen or that this functionality doesn't work. Can you please check? Besides that, we also have marketing. So marketing is the team that is analyzing user flows. So for example, let's say we implemented the screens and marketing team says, okay, we have 100% users here, 90% users here, and then we only see 5% of users here. That's weird. We dropping users 95% from transition on from this screen to this screen. Can you go and check it out? A drop like this is very likely some sort of a bug. So it's possible that there is a crash somewhere in between. And it actually makes sense to go and check and make sure that things are working. So marketing team will also be analyzing things. If there is a drop in our user engagement time, in the time users spend in the system, in the amount of money that users spend in our system, it is possible that they are also caused by the bugs. So marketing team will also reach out and ask us to investigate. Besides that, there is also customer success team. And customer success team is the one that will always communicate with people and they will process all those feedback in case people have certain issues, people can't use the system and so on. So this team is actually one of our best partners because if there are any bugs reported by users, they are very likely to contact customer success and that way somebody from customer success will usually reach out to QA and say, hey, so I have this user, they are using Android version 8. They say that when they click login, nothing happens, they cannot log in. Can you check it out? And we will basically go find this device and try to test it. So this is important to remember because when you are assigned things to basically regress, when you are responsible to do regression testing, it's easy to just mark some test cases as passed and actually not to verify things and not to actually test something. Don't do this because if you miss a certain bug and that was covered in a certain test case and then it gets discovered over here somewhere in production, it's usually possible to trace back to like whoever was responsible for this regression test. And it's ultimately going to be your fault that a certain functionality ended up being broken in prod. Now, it's okay if it's a certain, I don't know, link that doesn't open a web page somewhere that takes to our marketing site or to our partners or to our blog. That's totally fine. That's not too bad. But at the same time, if it's something that's related to our payments and users can no longer make a purchase, that's really bad. If it's something that is related to user accounts, that's also really bad. The company will lose money, and that's basically going to be on you. And besides that, the another side effect on this is that all these users who are experiencing all these issues, they will be contacting customer success. So they will literally slam customer success with hundreds, sometimes thousands of tickets. And this team will really be in hell if some serious bug is basically missed and made it to production. So treat regression testing seriously and really do your testing at the end before release to make sure that the things you are releasing are good because there's a big team that will be actually working and analyzing the product at the end. And it's important to keep things up and running very well. Now, one more thing. Actually, let me quickly check the chat and then I'll talk about one more thing. Let's see. Let's see. Cool. if there is a hot fix in the code, and we have to test it, what's the best describes this scenario? How about different platforms? We're going to talk about hot fix in a minute. Actually, that's the next thing I want to talk about. So I'll get back to this one. Who's going to assign us our tasks for every sprint? Usually QA lead or QA manager will assign you tickets. And that's basically how it works. Is it safe to say that the sprint and the channel are the same things? I'm not sure what is the channel, to be honest. So sprint is just a 2-week development cycle. That's it. Channel, I don't know what it is, so probably not the same. When you have negative comments to the developers in the sprint, do they get mad at you? And another question about hotfix. Okay, get back to hotfix later. So about negative comments to the developers, and do they get mad at me? Usually they don't. Usually, most of developers understand that we are the same team, and our goal is to release a good quality product. And for example, in the company I work, developers really love my testing and the issues that I discover because they are important, and I also describe the problems very well to the point where it's really easy for them to fix that. It's not like something doesn't work. My bug reports are very detailed, always easy to reproduce. So they usually appreciate it a lot. And they usually understand that QA and development is the same team. At the same time, it's possible to see 1 or 2 developers who get really personal about the issue. You report a certain bug, they're going to try to argue and prove till the end of the world that this is not a bug and so on. That's okay. Just if you disagree, you can always get QA manager involved. It's not a big deal. But overall, just try to be nice about things. Basically, don't act like, oh yeah, I found the bug, great, awesome, haha. No, don't act like this because that doesn't look nice. They don't like it. They get upset about bugs because that is their work, right? They were creating this build. This is their baby, and they really don't like when you just laugh at them when there is a major issue. Just be polite, be nice, and that will be success to building good relationships. That's it. Just work together, work with things together, and that will be fine. Let's see. Okay, the question about new hires, I will try to get back to that at the end of the class after I cover the rest of this. Why isn't regression testing not highlighted? Good comment, because I missed it. Good. I will do that. Are manual QA testers a part of customer success? No, usually they're not. Customer success team is the team that's responsible for communication with our external users. So they get some questions from users. They help our users. We are not the part of customer success, but we work with them pretty closely. So if users complain on a certain issue, they will very likely go to us and try to ask us to help and investigate. Do we have to do the regression testing on all the mentioned devices and environment? Usually no, but when you join the company, they will explain you how they do regression testing and how they split it. For most companies, what I see is that they split regression tests and they say like, okay, this 10 cases we execute on this device, this 10 cases we will execute on another device, and that's how they get to a pretty good coverage. So it's not like you have to execute 400 test cases on this device, on another device, and something else. Also, that is possible somewhere in Google, but again, it depends on the company that you work for, and they will usually explain to you how to do it. If we're catching bugs for them to fix on the same project, they will get upset. However, it's not our fault, simply our job, and they are simply frustrated. Yeah, that's legit, that's valid. Uh, they So the channel in Slack is the way to communicate. It's where all of us sit and where we all just discuss issues. That's the channel. Sprint is just 2 week cycle, 2 week cycle for work. So this is the difference. Okay, cool. So let me continue and let's talk a little bit about hot fixes. So hot fixes is another thing that may happen, and it happens in case you released something to production and then you find a bug in prod. And that bug usually is not crazy serious, but at the same time, it's something that we want to fix right away. We don't want to wait another 2 or 3 weeks in order to fix it. We just want to fix it quickly. So a hot fix will be a build that will include only one bug fix. So let's say we release to production, and then we notice that if we go to account and let's say click on terms and conditions, they doesn't open. So it's important, but at the same time, it doesn't like totally break user experience. Not like it's popular for users. Not a lot of people will be going there often, but it's part of our legal document, so it should work. So in that case, we will make a hot fix. We'll basically create a new build, and this build will only include one bug fix for this broken link. And then basically we will quickly test it within the next day. At that point, people very often, they don't even do the full regression. They just do as much of positive functional testing as they can during one day, quickly verify it on a couple of devices max, and then they just release it to production. So really very quick turnaround here, about 1, maybe 2 days in order to fix the bug. So that will be the hot fix. Doesn't happen often. To me, it probably happened maybe like 2 times within the last year in my previous company, not in the company I work for right now, but in the old one, maybe like a couple times within the last year, we've seen those. Again, not good when it happens, but it's usually pretty quick and easy way to fix them. So this is a hot fix. Now, sometimes though, we may release things that end up totally broken. So it usually happens when our environments are different. So let's say we got a build, we tested it in our QA environment, and then we release it to production, and we go to production, and now we see blank page, nothing works, no like website, it's all gone. So if something like that happens, the hotfix is not a solution because hotfix usually takes 1 to 2 days. And if something broken like that gets released, the way to go around it is basically to revert and go back to the previous version. So revert will be going back to the previous version if something is absolutely broken. So let's say right now we have a website version 3 that is live and running. We made website version 4. We tested it in QA. It looked good and nice. We released it to production. Nothing works. So in order to basically quickly fix it, what we do, we take our version 3 and re-release it on top of our version 4. Or sometimes we just get basically remove version 4 and just stay with version 3. In both ways, this is revert. This is basically going back to the previous version. And after we revert, at the same time, we can spend some time and try to investigate why that happened, why version 4 was broken, and how can we fix it. So this is revert. Again, another thing that happens. I hope it's not going to happen a lot. Now, the last thing I wanted to quickly talk about is A/B testing. So A/B testing, I quickly basically went, when I was going over this, mentioned that we released to production. In here, we actually, after we release to production, we can have a possible A/B split, and that is our A/B testing. So A/B testing is not a type of testing that QA does at all. This is type of testing that is done by our product manager. So when we build our product, if we go back here, at this point, when we come up with a certain feature, with a certain idea, that is a hypothesis, right? When product managers come up with something, they don't know if it's going to work in the future or if it's not going to work. Do we know if user is going to like this feature or not ahead of time? We actually don't. It's hard to predict. So A/B testing is the technique that allows us to actually separate our users' experience into different variants and analyze it. So what we do, we just install a certain software that allows us to basically separate the builds that our users see, and all our users into different buckets, into different categories, and then show one category of user, one group of user, show one variant, like variant A, and the second group of users will see a variant B. So for example, if we are building a new feature and we are not sure if user is going to like it or not, what we can do, we can implement A/B testing, and then we can release, and we only release this new feature, which is variant B, to, let's say, 10% of users. And 90% of users are still seeing variant A. They still see old experience. So although we just released a new app, only 10% of users see it. Everybody else is still having the old experience. Now our marketing and our product team analyze this user behavior, and they see, are users using this feature or are they not using? Do they like it? Do they not like it? How engaged they are? Do they make purchases? And so on. And if they see positive results, they usually bump it. So now we will have 50-50. 50% of users have old experience, 50% of users have new experience and the new feature. We keep on analyzing, and if we see positive results, if we like it, then our product managers usually just bump it to 100%, and all the users will see this new feature. So this is A/B testing. Now, if they don't like it, if they see that users who have this new feature don't use our app as much, are not so engaged, don't buy as much things, they will likely just remove it, and we will stay with the old functionality. So that's basically how a company is deciding which experience to show you, and what works best for the users. Companies like Facebook usually runs hundreds of A/B tests at the same times. So some users will see one button, some users see another button, some users see ads on the right side, some users see ads on the left side, and they constantly automatically monitor what is most clickable, what ad users like more, what place works best for users, and they constantly adjust their interface depending on those A/B testing results. So that is A/B testing. When we work for a company that has A/B testing, because not everybody has it, keep in mind that before release, we test, basically build with variant A, and we test the build with variant B. So our testing here actually gets more complex, and we have to test both experience. We have to test the first build and make sure that everything works, and users who see variant A, they still get nice experience and everything is good and running. And then we also check the build with variant B, and we verify that users still can see good experience and they have access to this new feature and everything works. So this is A/B testing. A/B testing is usually good for QA engineers because, as you may guess, when we just release, if we just go and release initially to, let's say, 10% of users, and there is a crash somewhere that we missed, we will see this right away, and only 10% of users will be affected. So it's not that serious that we miss a certain bug. But at the same time, it actually complicates things because now we have to do twice as much testing, one build and the second build. So that is A/B testing. Again, this is something that is done by product managers. So keep this in mind. That might be helpful. Possible A/B split. All right, so let me look at the questions. That's basically all I have for today. We had interview questions, which are kinds of testing performed, hot fix, revert, and one more, testing without documentation. So next time I will answer this question number 4, testing without documentation. We'll start with this one. These 3 we actually covered during the lecture, so I'm not going to go over those again. But we have a couple of minutes, so let me quickly check the chat and make sure to answer the ones that I have left. Let's see. Can we watch this video later? Yes, of course. I am always recording them, so they will be sent to you over email. How do you release to just 10%? What is the criteria for what some users see while others don't see it in A/B testing? So usually there is a software that developers install. There is a software that exists for web and for mobile apps. Developers just install it and add that software to the build. And then you can actually go into that software and you can modify the percentage. Usually users are picked absolutely randomly. So it's not like it picks 10% of users with certain criteria. No, it just randomly picks 10% of users and shows them one version of the app, and everybody else should see another version of the app. That software is usually just basically additional product that the company uses. And when they create a build, if they use A/B testing, you usually have access to that, and you can see and modify that percentage in that software. It's not something that your company builds from scratch. They just use existing existing solutions, and add them into the development libraries when they build an app, and then they can actually use it. That's basically how it works. All right, let's see what else. Not sure if you're comfortable with answering this, but what company do you work for now? And some you worked for in the past that you liked. All right, so I'm not sure I'm comfortable with answering this, but I currently work for a company that is called PAX Labs, which is an awesome company, and I do like it. We do build vaporizers. So we actually build vapors for smoking. And my job right now is actually build test automation that automates this Bluetooth device, and the way this Bluetooth device, the way it gets connected to the Android app. So that's what I actually do. And I also test all things related to this device and Android app. And also we have a web app, so I also test web as well. So I do like it a lot. It's a great startup, great team. But besides that, the companies that I worked in the past were mostly startups. So there were few companies in fintech, a few companies in mindfulness / healthcare. It was interesting. And I even worked for some sort of a QA agency actually in the past. Not QA, I'm sorry, tech agency. Tech agency was actually doing just multiple works, like multiple projects. We had like some project for one company, some for another company. We had like larger clients, like we built something for Boeing, something for PG&E, like all kinds of things. So I enjoy startup environment, and I kind of like pretty much all the places I worked for a lot because they were all interesting. Fintech was hard. fintech was probably my probably least favorite choice because it's very hard to test. There are a lot of limitations around banking, and just think about it, like you want to test a banking transaction. How do you test it without actual real banking card and things like that? Very hard, almost impossible to test in production because you need like real social security numbers and all that kind of stuff. So probably would be my least favorite, and it's pretty strictly regulated. But everything else I liked a lot. So that probably would be my experience. Let's see what else. Is it easy to shift from QA testing to user experience? Would UX designer be an acceptable answer during the interview? To where I see myself in 5 years. Yes, you can. I would probably still recommend you to, when you basically answer the question about 5 years, try to stick to QA. It's totally fine if you say you want to stick to with QA and then you join the company and a few months later you tell to your manager something like, I've been looking into UX design and it looks very interesting. I was wondering if there is a way for me to transition. Yeah, it's totally fine. People do it all the time. So you will be able to transition. That's usually pretty easy to do, as well as transition to like other things like development or product management. Your goal is basically to enter the industry, to land a job first. And then after you are there for maybe 3 months, maybe 5 months, basically, people understand, people like trust you. This is the time when you basically at that point build some relationship and you can start talking about other opportunities, and usually companies are willing to help. So even if they can't transition and turn you into a developer right away, at least they will try to help and they will try to find some resources. If you want to transition to, let's say, UX designer, they will likely just basically contact you with a couple of designers so you can talk to them about what's the expectations, what should you learn, and they may guide you a little bit. It's better than nothing. Sometimes if company has a budget, they may even pay for like additional schools and things like this. So the goal is just enter the industry and then you can basically shift whatever you want. That's much easier when you already have a job. That's basically the approach. Why did you recommend to jump jobs around a lot? Let's get back to this tomorrow, because tomorrow we will be talking about negotiation. Uh, Long story short, because that's a very quick way to raise your salary. But we will talk about this tomorrow. Do startup companies post the jobs in Dice, Indeed, etc., like the larger companies do? Yes, they do. My personal favorite resource for searching a job would be Glassdoor and LinkedIn. I would recommend you to start with this too. Because there are more jobs. Dice and Indeed, they have a lot of jobs that are posted by recruiters, and they usually used by recruiters pretty heavily, and you will get a lot of recruiting calls that are not direct from the companies, which is like basically additional step. If you want to talk to companies directly and faster, better use Glassdoor and LinkedIn, because startups definitely post the jobs there. That's like their first source. And when you apply for a certain job in the Glassdoor or in the LinkedIn, it goes straight to the company. It doesn't go to some sort of weird third recruiting firm and then makes it somewhere to the company, ideally, or maybe not. But yes, I do post jobs there as well. Startups pay more, right? Hmm. The biggest the biggest offers I've ever had were from Amazon and Netflix. So I would argue with the statement, but startups pay a lot. Yeah, that's good. Uh, Sure, happy to share the knowledge. And I think that's pretty much it. All right, cool. So let me actually go back one more time. I'm going to answer one last question from Natalia. Pretty much everybody else, I think I answered everything. So feel free to drop off. Meanwhile, I'm just going to answer the last one and I'll see everyone tomorrow. All right, so let me read the last one from Natalia. May you please say from your experience how new hires survive these days? In the past, I guess there was a chance to ask someone in the office. How about now? Regular calls, emails with QA lead manager. I'm pretty sure if you are new to the field, there will be tons of questions. What would you recommend? How to survive and don't look incompetent? Yeah, that's a great question, actually. So remote is a little bit higher, and right now with COVID, everything is remote. So my first advice is don't be shy and don't be afraid to ask questions. So when you just join, usually company will have some sort of onboarding process for you in place, and onboarding can take actually up to a month, but usually it's at least 1 week. And during the first week, the company will be spending some time. They will be sending you some documents to go through to read. They will likely assign a person like a QA teammate who will be answering your questions, and manager will be there for you to also help you with things. So keep in mind that nobody expects you to learn things like right away. Usually people are totally fine with new hires to take in some time, up to 3 months, to actually learn the product and start doing things. So nobody's just gonna expect that you're gonna be top best performance from day one, week one, or even months one. No, that's not the case. So usually people totally understand that it takes you at least 2 weeks to just kind of start understanding what's going on, and it can be definitely longer. So when you start working, go through documentation that they send you. Basically research, look at the resources that you have, so that can be helpful to answer some questions. And then don't be afraid to ask questions from your teammates. If you have a few teammates, I would usually split my questions. So like, let's say I have two QA engineers who work with me at the same time. I would like come up with 2-3 questions by the end of the day, and let's say I ask the first person, and the second day I'm going to ask the second guy, and then back to the first one, and so on. So like, just split it between a few people if possible, so that way it's just like less bugging of the same person. That will work. But even if you don't have this many resources and you only have, let's say, one QA manager or one QA person, don't be afraid. Just ask, and they will be able to help. So people really treat you nice when they see that you are interested and see that you are trying and doing your best to figure things out. They will be willing to help. So don't be afraid. That's totally fine. We all don't know things, and I don't know half of the things when I join a company. And I mean, honestly, if you had an idea how many questions I asked about, like how do I even automate a Bluetooth device, that was probably tons. So it's okay. Just ask and then you'll learn. And then keep in mind that we don't disappear. The school still exists. So if you get to the point where like you feel like it's way too much and you totally lost and like missing or cannot understand something, just reach out to the school. We have mentors, we have Max, we have Yuri, Natalia, myself. And if it's something technical that you can't cope with, we will just jump and we will be able to basically help. Just try to figure it out yourself. Try to talk to teammates, but keep in mind that if it comes to worse and you don't understand anything that's happening, you can always ask us, and we will try to do our best to help and answer the questions. So that's basically the idea. All right, so I hope I answered everything. Thank you all for great questions. And I'll see you all tomorrow at the same time. Have a great night. Bye-bye.